master's students, undergrads, and then these are collaborators. And then especially thank you to people who have helped fund all this great research. And thank you to you for your attention.
Imagine there might be a few questions.
Yeah.
Yes, Aaron. When you're trying to determine a change point in a non-stationary time series,
Yep.
how much data or post time is required to be able to, with a fairly strong degree of confidence, determine that you have, in fact, reached a change point?
That's a really good question. Let me go back to a slide so I can use that to illustrate the point. OK. So suppose that we have this time series of networks. If all we see is up to this point, right, so there's one network drawn from the new model, then we fit the models are fitted to this part of the window. And this data is going to have some probability under the previous model. If that probability is really, really tiny, meaning that the difference between this part and this part is really big, we might only need one network to observe that there's something happening here. But if the shift is only subtle, then we're going to need more data, more networks to see that. So we characterized the sensitivity. There's this thing called the alarm time that in the change point literature people use to quantify that idea, which is how much more data do you need before you know that there was something happening back then? When does the alarm go off that something happened? And in our synthetic examples where we actually know where the change points are, we find that we do pretty well. We can get it within like 2 or 3 network snapshots. And that seems